Assalamu alaikum class. Hope you all are fine and doing well. Let's start our today's topic. Our today's topic is electropositivity and nature of oxides. We are going to discuss the electropositivity in terms of nature of oxides. Before starting the topic, let's refresh our minds with some questions from the previous knowledge. What is relation between electropositivity and reactivity of metals? How electropositivity changes and how reactivity changes according to electropositivity in the periodic table. How reactivity of alkali metal changes down the group, moving from top to bottom. Either the reactivity of metals increases or it decreases. How reactivity of period 3 elements changes across the period, moving from sodium to silicon, how electropositivity value changes, and according to that how reactivity changes. Can you relate the electropositivity with metallic character? If yes, then how? Give some examples of acids. Give some examples of base. Take a pause for 5 minutes and answer all these questions. Starting the main topic of today, the question that arises related to the topic is: trends in electropositivity can be observed from the nature of oxides. Elaborate. You have to discuss the electropositivity character in terms of the nature of oxides. First of all, let's describe the nature of oxides. Either these oxides are acidic or basic or amphoteric or neutral. Talking about the metal oxides are basic in character. Why? Because when these oxides react with water, they produce bases. So in this way, these oxides are basic in character. Here is the reaction shown, which is describing the basic character of metals. Sodium is a metal, and sodium oxide, when reacts with the water, it gives sodium hydroxide, that is a base. So this reaction shows that metal oxide is basic in nature. Non-metal oxides are acidic in nature. Why? The reason is same. They produce acids in water. When these oxides react with water, acid is produced. Here is the reaction shown. Sulfur dioxide is a non-metal oxide. When it reacts with the water, it produces sulfurous acid. So this reaction shows us that non-metal oxides are acidic in nature. This was all about the nature of oxides, which oxides are basic and which oxides are acidic. We have discussed that more electropositive elements are metals. It means that if an oxide is basic in nature, this is the oxide of metal, and that basic oxide will be from the more electropositive element. Similarly, if the oxide is acidic in nature, that oxide is from non-metal, which is less electropositive. Let's discuss the trends of nature of oxide in a period. The basic character of oxide decreases as we move along a period. This shows the decrease in metallic character and electropositivity. As we move from left to right, basic character decreases. Oxides at the start of the period are basic in nature, but at the end of the periods are acidic in nature. This change is showing us that the metallic character is changing because metal oxides are basic in nature while non-metal oxides are acidic in nature. So if we are having a non-metal oxide at the end of a period, it will be acidic in nature. As the basic strength decreases as we move from left to right, it means that acidic strength increases moving from left to right. The oxides change from strongly basic to amphoteric to acidic. At the start we will have basic oxide. At the middle of the period we will have amphoteric oxides. Amphoteric oxides have both properties. They act as acidic as well as basic oxides. And at the end of the periods we have acidic oxides. Oxides of period 3 elements are shown below in the table. From this table, we can observe that moving from left to right, nature of oxide is changing. Sodium oxide is strongly basic. The first element, that is the sodium, its oxide is strongly basic in character. The second element, magnesium, its oxide is basic in nature. Moving towards the next element, that is the aluminium. Aluminium oxide is amphoteric in nature. It means that it can act as an acidic oxide as well as basic oxide. Silicon is weakly acidic. As silicon oxide is weakly acidic, we can say that from magnesium to silicon, now we are moving towards the non-metals. Phosphorus oxide is acidic. It means that this is a non-metal because non-metal oxides are acidic in nature. Similarly, sulfur oxide is strongly acid, while chlorine oxide is very strongly acidic. So, from left to right, the nature of oxide is changing from strongly basic to amphoteric to strongly acidic. Let's discuss the trend of nature of oxides in a group. Moving from top to bottom, basic character of metal oxides increases. This shows that increase in metallic character and electropositivity. It means that the element at the bottom of the group is more basic in nature because it is more metallic and its electropositivity is more. As we have discussed earlier, that we can describe the electropositivity in terms of the oxides. If we are having a basic oxide, it means that that oxide is from a metal and metals are electropositive in character. So moving downward, the basic character of oxide is increasing. It means that the metallic character is increasing, and if metallic character is increasing, it means that electropositivity is increasing. Considering the elements in a group to a group, the basic character can be described by this relation, that basic character increases as we move down the group from beryllium to barium, and as the electropositive character increases, it means that reactivity also increases. So when these oxides come in contact with the water, the oxides at the bottom give more reactions, violent reactions. Here is the practice exercise from today's lecture. The question 1 is, identify the more metallic element in each of the following pair. 5 pair of elements are given here. You have to describe separately that which element is more metallic. Considering the lecture above, considering the electropositive characters, you can describe these metallic elements very easily. The second question is, using the periodic table, rank each set of elements in order of decreasing metallic character. 2 sets of elements are given. You have to rank them in decreasing metallic character. It means more metallic character element will be written first and least metallic character element will be written at the last step. The third question is, which is more basic, lithium oxide or sodium oxide? And you have to argue on it. Means you have to give reason. Whichever oxide is more basic, according to you, give reason for that. That's all for today. Let's do a quick recap. We studied about the electropositivity in terms of the nature of oxides. That how describing the oxides of elements we can describe the electropositivity. Metal oxides are basic in character because they produces bases in water. Non-metal oxides are acidic in character as they produce acids in water. Basic strength of oxides decreases across the periods, moving from left to right. At the start, we have more basic oxides and at the end, we have more acidic oxides. Similarly, the metallic character also changes. At the start, we have metals and at the end we have non-metals. Basic strength of oxides increases down the group, moving from top to bottom. The basic character increases because the metallic character increases and metal oxides are more basic in nature. Thank you very much.